This conference will now be recorded.
So, how many of you have heard about Nielsen, Ipsos, and there are many other companies. All they do is mostly marketing analytics, like MMA. You have heard of the term MMA, so that revolves around marketing analytics, and to some extent, some other divisions like customer segmentation, customer sentiment understanding, all those things. So I have chosen a specific topic from that particular domain, which is market basket analysis. So you guys might be familiar with Amazon, Flipkart, shopping over there. So what is the first thing that you try to do whenever you find a product? Any kind of sorting specific? What things do you do? Like sorting from price high to low or low to high, or the newest, the latest arrivals? So once you go over there and search for a particular product but don't buy it, what happens immediately? You immediately, after some time, you receive a mail from your registered email ID that you have so and so products in your basket, but you haven't purchased them or ordered them. So what happens is, like, they record your search preference. They record your search preference, and the next time you visit, they go and recommend you the same products or some related products that you had searched from the last time. So what algorithm works behind that? That is what is we look that is what we will be discussing over here. What algorithm, and what is the need for such an algorithm? There must be some logic for which they have set up some recommendation engines over there. What is the logic? Why do they need such logic? So firstly, if you look at the business motive, we know that Amazon, Flipkart, every e-commerce company, and nowadays every brick and mortar retailer, those people who have stores, physical stores, they have a profit motive. Okay, so what happens is, like, they want to increase their profit over time, and that too at the minimum cost of investing. So that's why they have this logical algorithm at the back end, which helps them to identify that today Orco is coming to Flipkart and trying to buy, suppose, a pair of gaming keyboards or gaming controllers. So the next time when he visits, it might be, or there's a high probability that he is going to buy something related to gaming, like video cards, like steering wheels. So basically what happens, uh, whenever you go and try to search one product, the algorithm engine at the back end records that activity, your clicks on the website, and logically builds a predictive algorithm, so that the next time you arrive in the same site, they can recommend you something useful, so that you ultimately end up buying that product. That is the ultimate target. So let's focus. So don't look at the written text over there, just focus on whatever I'm saying. So first of all, it's very common that every retailer nowadays are moving to the online platform, right? So there are some perks and hassles to that. What are the perks? Definitely there are plus points, like they can display the product category, the product range, in a wide and easily approachable format. If somebody is interested into gaming, that particular person will go to the gaming section and try to see what are the products available under his or her budget range. Whereas whenever you go to a physical brick and mortar store, what happens is, like, you go to the store, approach the customer, the shopkeeper, and ask him that I need so and so product, or maybe a gaming controller. I need a so and so gaming controller under this and this range. What happens? The shopkeeper has his own preference, right? He knows that from his knowledge, something is better than the other. Some product is better than the other. What he tries is to force his own decision on you in many cases. Like, he tries to tell you that this is better than this, please buy this, without any valid logic or valid proof of that. What happens over here in this algorithms that the online retailers do, they have a valid proof from the past record, past historical data, which leads them to recommend to the recommendation engines. It's not based on any subjective call. It's based on a calculated, quantifiable, decision-making algorithm. So we'll be trying to focus on that algorithm. So this went from the seller's point of view. I mean, what is in it for the seller? What perks do they enjoy? Now, what perks do the customers enjoy? First of all, if you look at this particular price comparison picture over here, what happens is like whenever you go into an online forum, online marketing platform, you get comparisons of price. Earlier, Amazon.com used to do this. They used to compare prices of the same product across various other sites, related sites, e-learning, e-marketing platforms. So what happened? The same product that you see over there, it has different prices across different platforms, right? So Amazon used to do is like they used to guarantee the consumer that this is the lowest price available in the market. With this comparison, they would see that Amazon.in or Amazon.com had the lowest price, and they are convinced they go in for purchasing that product for sure. That was the technology or the strategy used then. Nowadays, Amazon.in doesn't have that amount of price comparison, whereas other sites do have this price comparison. Like if you want to buy this product at a cheaper rate, you have other portals. If you want to buy this product at a standard rate but the delivery will be faster, you have our portal like this. So the whole idea is to study past data, identify the patterns in the buying tendency of the customers, and then predict that if this customer comes up the next time onwards, what will be the most possible product that he or she is going to purchase along with some other additional items. That is the ultimate target. So doing this reduces the cost of approaching a customer, cross-selling products to him or her. So this is all a scientific and logical algorithm which helps to meet the target. That's all. Nothing rocket science about this, but definitely this algorithm has several parameters which we'll be covering over here. So if we look at this particular invoice, right, this is a Walmart invoice. We see that there are several items. Okay, some have repetitions, some have been clubbed together. Like bananas have been clubbed, 1 pound or 2.78 pounds of bananas have been clubbed together. And some are like Roman hearts, cherries, chicken broths, they have been segregated. So usually what happens, people go to a online platform, be it Amazon, be it eBay, be it Flipkart. They select one particular product that they're interested in. Suppose I go to Amazon and I am looking for woodland shoes. Suppose I pick up the right pair of shoes that I want, I put it in my basket, and then again continue shopping. That is the usual trend. Now this time, what do I look for? Yeah, I look for something which is complementary to the product that I've already put it in the basket. Like shoes are complementary with some shoe polish, like cherry blossom, kiwi, whatever. Socks are complementary with shoes. So what I can do is like whenever I go for a second round of shopping, putting the first article or first item in the basket, the e-commerce site takes up this opportunity. They go for a random search of my preference pattern or past history of my purchases. And whenever they come up with a solid idea, solid pattern that this particular user have shopped from our portal, say about 50 times, and each of the times whenever he has purchased something of a higher price, he has gone on to purchase something which is complementary to the particular product. So once I go for shoes, Amazon understands that I might be buying socks or a kind of polish, shoe polish. So what happens? What happens is that they immediately recommend this product like kiwi blossom or cherry blossom kiwi or any kind of shoes, any kind of socks, shoelaces, whatever. So this is done by a particular logic, and you will hardly find any algorithm which is predicting or recommending you food where you have bought a pair of shoes. This is, if that happens, this is the worst case actually. So that is the target, to predict the right pair of items with the things that I have already bought. So why then a market basket? Any idea? Any students of economics or statistics, or any business oriented people from business oriented background? Why market basket? People online, can you tell me why market basket? Anyone? Guys online, can you hear me?
Hello, sir.
Yeah.
Hello, sir. So, in economics, consumer theory, consumer always prefer a bundle of commodities and chooses among them. Market basket is a preference list of consumers where several types of commodities exist and consumer preferences among them. Prefer among them.
Okay, that's
So we do market basket analysis.
exactly, that's one of the most perfect answers that I've ever received. So if I go by the economic logic, the logic of business or any economics, market basket is like a combination of products or items that I purchase quite frequently. That is a market basket. Why do I purchase that very frequently compared to other products or other baskets? Because I personally prefer that particular combination of items over other combinations. So in economics terms, we call it revealed preference or revealed preferred. From, one item is on one item basket is revealed preferred to another item basket. So that particular logic comes in as a psychological factor to every buyer whenever he or she goes for shopping. So as the name mentions, market basket analysis, we are trying to analyze the pattern of preference that consumers usually have over any product that I, as a seller or retailer, try to pitch in for to the customer. So if I am, say, Walmart, I will try to analyze what are the patterns or what are the preferred consumer market baskets that one buyer will definitely prefer over other market baskets. That is the whole idea. So if I successfully do that, I'll be able to predict or recommend better from the next time onwards. And the buyer, whenever he or she comes back to my portal or my site, will be having those recommendations ready. So this will kind of build a goodwill, a good image of my site to that customer, and as a result, the sales will automatically go up. So nowadays, in the age of online shopping or online, marketing, online advertisement, many of things depend upon goodwill. Amazon has a goodwill which can never be touched. So it is much higher above Flipkart nowadays, though Flipkart is tying up with Walmart and all those things. So the name is market basket analysis. We are trying to analyze which particular combination is preferred to some other combination. That is the whole idea. So I'll analyze, definitely. I'll try to analyze. But what will it fetch me as a result? So what will it fetch me as a result? First of all, if I look at the picture, we'll see that the shopper herself is a little confused. Okay. So what to buy? Many a times we go to the shopping mall and we find that there are numerous products of the same category that are arranged in stacks. So which brand is better than which one, and which will be suitable for my budget or my requirements? Maybe I myself as a consumer is very much confused which one to buy. So what we'll do, as a seller, you will try to make the particular deal a confirmed one. So that the customer who is in a dilemma is going for a particular product for sure. That is the target, right? So what will happen is like the seller will have this algorithm ready, and whenever the buyer seems a little perplexed or in a dilemma regarding what to buy and what not, the seller himself or herself will pitch in with this algorithm, with these recommendations, so that the next time he or she, the customer, faces a dilemma, she doesn't have any doubt that this seller will be guiding me right. That whatever products I need will be the ultimate recommendation from this, I mean, uh, e-commerce retailer. So the second thing that I need is, this is all about understanding the buyer's need, because the customer is like God to the seller. So if I don't cater to the customer's need, my business will be washed away. So this was one of the targets. The second targets, as you can see in the picture, is like, there's a very good joke that nowadays comes up as a meme in Facebook. Like when male customers enter the shop, they come in to a particular direction, shop, and just go out. Whereas the female, this is a joke, don't quote me on this. I just used it up from Google. So when female customer enters, they try to roam around the entire shop and try to select products that will be best fitted for their budget. And then they end up buying. So definitely, the what will happen is the e-commerce retailer will be having different strategies for male and females. So whenever you go for a female section, like the whenever you go for the the female section, like the dresses, the jewelries, the bags, you will see that particular section occupies more space than the main section or any other general section, because female people usually generally like to roam around the shop, understand the pattern in which the things are placed, and then select the right product. While the male guys, whatever they have in their mind, they'll go in, just select a random product of that category, and if they are satisfied, they'll buy and come out. That's the general. I'm not trying to specify that you do it or you don't do it, but this is the general trend. So the idea is like, the retailers, what they do is they understand the buying pattern of male and female separately and try to decorate or organize the racks, the shopping pedestals in that manner, which will facilitate higher sales. That is the ultimate target. And obviously the last one is to capture new buyers. People who haven't visited your site, they'll be the most lucrative things to touch upon by the new by the retailers. They'll be trying to acquire more and more customers, like Amazon will be trying to acquire customers who are loyal to Flipkart and the other way around. So we need to understand several concepts before going for the details in the R code. Like if you look at this, so don't look at the equations. I'll be explaining each and everything in a layman's term. So everybody knows items, like items are products. Individual products which are distinct from each other are called items. So suppose, what is your name? Sunil. So you suppose Sunil goes on to a random physical shop, brick and mortar shop, and tries to pick up a basket. So what will he do? He will try to pick up products and put it in the basket until and unless he has fulfilled his entire demand. Whatever he's requiring, he has fulfilled all the products that he needs and have put all those products in a basket. So the first thing that Sunil will be doing is looking for the most important item, the item that he needs very deeply or very urgently. So what happens is, like, the first item that Sunil picks up and put it in the basket is I1, and the next item that he goes on to pick up, suppose he picks up a pair of shoes, and the next thing that he picks up is a pair of socks. That is I1, I2, and so on. It goes till IN. Sure. So this goes on from I1 till IN. N can be any natural number like 3, 4, 5 integers. So suppose he's buying five items. What happens is, like, he picks up one, then goes on to pick up the other rest 4. Okay. So capital I is the combination of all the products. It's the basket that he has picked up. So a pair of shoes, cherry blossom, socks, shoelaces, these things together combine the basket that Sunil has picked up. Now, I do not stop whenever I have picked up anything. I go on to the counter, the POS points, and go for a billing. What happens sometimes is like I go for different billings. Okay, I do not want to bill the entire basket in one transaction or one bill. So what happens, I go for multiple billings or even one bill. So each bill that I have generated has a transaction number over there. So those are transactions. So what happens, a particular transaction item might have several, product items in it, whereas one particular item should have necessarily one transaction number. Okay, so not the other way around. One transaction number may correspond to several item IDs, but one item ID necessarily at one point of time should correspond to one transaction ID. So if there are two different buyers, they will have two different transaction IDs necessarily. So these are transactions. So there are about say 10,000 such transactions going on each and every day, right? So for all these transactions, we have a database. Like in SQL, we do is like handling and merging databases. So this retailer has databases at their backend. They have servers where they have loaded this transaction copies. Like we have our invoice, they have the digital copies of those invoices, recorded and structured. What we have in a printed form are like unstructured. They are tabulated, one written one below the other in a list form. Whereas in a database, they have more or less structured formats of those invoices. So once we have a database of those invoice, what we can do is we can do this analysis. So like as I've mentioned, this TN, there is a transaction, nth transaction will be comprising of say key number of items. Okay, ij till ik, whatever be the number. So there may be 5, there may be 20, there may be 10 items together to form a transaction, to form one single bill invoice. So you will have these documents with you once I end up the session, and you can go through it in detail. So coming to the next things, so these rules from now on, what I'll be speaking is like more relevant to the algorithm. Rules we do not observe generally. A buyer, whenever he or she goes in, we do not observe any rules that we like to buy in. We do not have any logic in our mind. We have certain preferences, but we do not have logics, standard logics that if I do this, I will do that definitely all the time. That is not what we are. At least we, in India or in Kolkata, we do not do that. We do not have standard logics. Those logics are not recognized in our own mind. The retailer might understand or recognize those logics, but we as a customer do not have those ideas. Okay, so that is the requirement for rules. So what does a rule mean? A rule means if Sunil goes into the shop and buys 5 products, I1 to I5, it is very much evident that the 6th product that he is going to buy will be some I6. Suppose like if he buys shoes, cherry blossom and shoelaces, it is evident that the next product that he'll take up into the basket will be socks. If this is certified, if this is guaranteed from the seller's end, then definitely this is a good algorithm or a good rule mining algorithm that the seller has deciphered. So it is very hard sometimes for people to understand this by their own selves. So that's why we need the logic, the algorithm to be built. As for example, somebody goes and buys flour and sugar. So it might happen that this particular person will be looking for eggs also. So they will be mixing up eggs, sugar and flour to form some dish. So that is the whole idea of rules. So the left hand side of the implies that sign is present already, and the right hand side is something which you are predicting that this will follow the left hand side automatically without any doubt. Well, without any doubt has some subjective calling. There has been some degree of confidence to which we can state that without any doubt. Okay, like we have confidence intervals, 95%, 90%. So out of 100 times, 95 times it is certain that this particular value will lie within these two zones, these two boundaries. Similarly, if I go for a confidence zone of say 90%, we might say that out of 100 times, 90 times it is, recommended that this particular person will buy the sixth item as socks and not any other article. That is the whole idea of market basket analysis. So next slide is mine. Yeah. Now, this is a very important concept like support. Well, support is something which is present directly in the data set. Okay, I'll explain something. Suppose you analyze a bunch of invoices. Suppose Sunil goes over there, Pratik goes, I go. There are many other people in this room. They go for buying different products from the same retailer. That retailer will be having about 20 to 25 invoices with around 5 items in each of those invoices. That is 100 products, not 100 unique products, but 100 products purchased. So what will happen is like the retailer will try to analyze what is the buying pattern of this particular group of people or the class of people, and accordingly whenever one of us will go and try to purchase something from the same retailer, what will happen, they will try to predict, oh, this guy had visited my shop about 1 month back and he has purchased these so and so products, so definitely this time if he picks up any one of those products, definitely the rest of the products are going to follow suit. That is the logic that they will be building in order to cater to the customer. So what is support? Suppose there is a direct relationship that the left hand side will imply the right hand side directly, and that is present in the invoice data. We do not have to find any logic or any statistical predictions. We do not have to do any statistical predictions to find out that this implies this, but that is already present. Like, as I said, Sunil has purchased one shoe, and along with he has picked up one kiwi or cherry blossom, whatever. That means there is support in the data which proves that whenever he is going to buy one pair of shoes, he is going to buy one cherry blossom. There is a support. But suppose Sunil goes on a different occasion and tries to buy socks only. The first item that he picks up is socks. There's probability that he is going to buy other garments also, barring the shoes, because he started with socks. Socks, maybe jeans, then maybe caps, maybe jumpers. Is it like sample of data which supports? Sorry, just a second. Is it like a sample of data which supports the rules? Yes, Shoptoshi, it is like a sample of data which supports the rule in reality. You are correct. So it's a subset of the entire invoice which is present over there. There is sample, and it supports our claim that this is going to follow this, that product B is going to follow product A. We did not do any kind of statistical calculation, okay, in that case. So there is a support. And for small retailers, what happens is support is very less. I mean, small retailers have fewer transactions in a day and fewer repetitive transactions all the more. So what happens is like the pattern, inherent pattern in those transactions is very less. So for as a substitute for support, what we have is like confidence. Like, as I've mentioned, confidence is something which attaches itself to my predictions. Whenever I'm going to do some predictions, I am going to make use of my confidence that I am predicting this product will follow those products with the confidence zone of this. Whereas support doesn't need any confidence, it is already present in reality in the data. So we make use of already present patterns in the data, in the transactional data set, and try to predict something which is not evident. But this non-evident fact that we are trying to predict with accuracy will help the retailer to retain its customers and to cater to new customers also. So this goes for support. Like whenever we go for, in foreign people buy container, packaged milk, condensed milk. Over here also we have packaged milk. So whenever people go for buying condensed milk, it's evident that some of them will buy bread. So this is, if this is present in a data set, this is support, that bread is supporting the purchase of milk, or milk is supporting the purchase of bread. That is.
So let me ask you a question. Suppose if we talk in terms of not a retail, but let's say talking in terms of bank.
Yeah, sure.
So let's say someone is buying credit card, someone is taking credit card. So do you think that will support FD also? Credit card
If
with-
not FD, definitely any savings account, definitely a savings account. If not FD, definitely a savings account. So if suppose I have my corporate salary account and it's necessary for me to have, it's not necessary rather for me to have a credit card. But if we look at me purchasing or going for a credit card, definitely the support is on the other way around, that a credit card implies that I have an account over there, but not the other way around. If I have an account, I may not have a credit card for the same bank. But if I have a credit card for my corporate account or corporate salary account, I should have an account over there. So, I mean, this is a subjective call. Support is very rarely considered as a parameter for understanding how good the, algorithm is, because very few retailers have that huge amount of data as a database to analyze, because small retailers are also there, they also implement this algorithm and they look for confidence. There is indirect pattern, not direct pattern, which is also present, but we need to mine that algorithm.
And how do you find out confidence?
Yeah, so what is confidence? Out of 100 times, my algorithm says that out of 100 rules that I have made,
Confidence interval.
exactly 100 rules that I've made individual, about 80 times those rules are including two whenever there is one. So there is 80% confidence or 90% confidence, whatever. But support is something which is already present. Okay, that is direct. We can see it from the transactions only. We did not go for any algorithm. Because people nowadays are very diverse, they have diverse choices, so support is a very rare thing nowadays. But yes, retailers like Amazon, Walmart, they have support, they have high degree of support in their analysis, definitely.
The more organized retail.
Exactly, the more large scale it is, they have better resources, better data, and more loyal customers. That is where the support comes in from. So next, so there comes the confidence. So don't look at the formula. The formula is definitely in the set theoretic terms, like support of one particular item union the other item. There is IM divided by support of IM. So this is like probability A union B divided by probability of A. That is the confidence. So don't focus on this, because you will never require these formulas to be calculated. All the things will be done by R itself. So you need to understand the steps only. Well, when I'll be running this code in the R markdown that I'll be using, you'll be understanding which step comes after which step and why it is required. That is the most important thing. Now, another important concept is lift. So what is lift? Anybody has done logistic regression over here? Lorentz curve, lift curve. Okay, yeah, sure. So if people from economics are there, they might be knowing there's something called Lorentz curve, right? Which measures the degree of inequality, like Gini coefficient. So what happens is, like, the lift is something which indicates how good the presence of particular items in the left hand side is helping me to predict the presence of another item in the right hand side. So something which is present in the left hand side, that is the mth product, implies the nth product, and along with the mth product, if I incorporate suppose a kth product, and that means that definitely in will be there, that means the lift has gone up. I'll explain it in a layman's term. Suppose I buy a pair of shoes and I can predict that I'm going to buy a pair of socks with a probability of 0.6, suppose, with a confidence of 0.6. Suppose the moment I change or reframe my statement to that I have bought a pair of shoes and shoelaces, it may happen that the probability with which I am guessing that the next product will be a pair of socks is increased to 0.8. That is the lift. That is 0.6 was the earlier probability. Now it has risen to 0.8. So any rule which gives us such an idea that the probability or the confidence of my prediction goes up is the lift. That is, if I look at, I'll explain just a second. Suppose uh, what is written over here is the ratio of support on the left hand side to the ratio of to the support on the right hand side. What it means is, like, if in a data set I have 5 items on the left hand side, and that is present about 500 times out of 1000 line items, like 1000 records I have analyzed, and out of those 1000 invoices I have 500 invoices conferring that 5 of those items are there in the left hand side. That is surely selected into the basket, whereas 200 out of 1000 times I can predict that the item on the right hand side will be following the item on the left hand side. Okay. However, if suppose I include a 7th item into the left hand side basket, and the confidence of the item on the right hand side increases very much, that means there has been a lift. So if you calculate the confidence of the left hand side, that is the basket that is already present, that is already I have bought, and the items on the right hand side, that is I am trying to buy, that I might buy. Suppose I have bought a pair of gaming keyboards and gaming controllers and a keyboard. So this together predicts that I am going to buy a gaming mouse. Whereas whenever I include another item, suppose 16 GB video card into the basket, it increases my prediction power of predicting that the next item will be a gaming mouse rather. So this is the lift, the ratio. Whenever the ratio increases, we say there has been a lift in the prediction. Like whenever you will go for logistic regression, you will go for the concept of lift curve or Lorentz curve in economics terms. The more deviating the curve is from the 45-degree line, you'll find that the more accurate or the more goodness of fit is for our model. Okay.
Hi,
So
hi,
similarly
Ankur.
over here, the same thing.
Hello, Ankur. This is Randeep. Hello, are you
Sorry?
able to hear me? Are
Yeah,
you able
sure,
to hear
sure.
me? The
Yeah,
thing is
yeah.
that I have a question. Like you have discussed about the left rule. So might be I'm a first-time user of Flipkart. I'm going to purchase a laptop from their website. So they do not have my historical data that for which right option I'm going to look for. So
Yeah,
are they when we going to buy a laptop, they refer us. You can go for a antivirus. A lot of
exactly.
customers who purchase the laptop, they buy antivirus from our site, and these are the options that are available, so you can go for that also. So are they
Exactly.
using the left rules for other customers, the historical data?
Exactly, you're right on your track. Actually, they are trying to analyze your character or your profile by matching with
Hmm.
similar customers. Okay, so customers who have been loyal to that particular brand and have purchased similar type of products,
Hmm.
they have their data, and they try to
Right.
analyze their data and to fit in into your profile, so that
Hmm.
their recommendations for you as a new customer are as much perfect as possible. That is the whole idea.
So they are following out the left formula for myself based on their historical data.
They do not have any left basket for you, but they have a left
Mhm.
basket for
For other
similar customers.
customers.
Exactly, exactly.
Okay, thank you.
Yeah, sure. So moving on to the next slide. 3 points to be noted. Don't look into this all these details. 3 points. If lift greater than 1, lift less than 1, and lift equals to 1. So lift greater than 1, what does it imply? The presence of LHS implies that the probability of the presence of the RHS will increase. Lift greater than 1, definitely. Lift less than 1, the presence of the items on the left hand side indicates that the presence of the item or items in the right hand side will decrease. That is a bad rule that I have come up with. And lift equals to 1 means you're kind of constant, kind of indifferent, that if you buy this product, you may go for the 6th element or you may not. There's a 50-50 chance. And in most cases, we look for lift greater than 1, definitely. Lift less than 1 means there's no point in applying that particular rule. Whereas I know that Sunil has bought 6 products, and I know the 7th product has very less probability of being included in the basket. There's no point in implementing that. That is that is not a wise choice. That's all. And regarding comparison between lift not between support and confidence, whatever data set that you get, it depends on that. Suppose you have a big data set, there are a lot of transactions over there. I mean, like Amazon, Walmart, whatever transactions you get, they are big in numbers. The amount is, towards the higher end. The number of transactions, the items included in each of these invoices are on the higher end. In that case, you can try to go for maximizing or optimizing rather the support. Whereas whenever you have a small retailer which do not have that amount of data available to analyze, we go for optimizing, rather maximizing the confidence. In most cases, confidence is something which we can optimize, whereas like if we go and try to optimize the support, we may fail. Such rules may not exist for that particular retailer. So we'll show that over here in the analysis. So this is the whole algorithm, which I'm not going to explain.
Sir,
Yeah.
Sir, like in Lorentz curve, we have a 45-degree line which shows that there is no inequality. Do we have something like that in this lift curve? I mean, if, then what does it mean?
If equals to 1, that is the indifference zone.
Okay. And if left is greater than 1, then it will be on the upper side of this 45-degree line.
Exactly. That's the correct thing.
Okay, sir. Thank you.
So this is the whole algorithm, which I'm not going to explain because this is something like a black box. Once you look at it, you forget everything. So I'll explain something by taking examples, not the set notations. Fine. So this particular thing that I took over here is found in Wikipedia. You need not go through it. If you are some of the students from computer science background, you can easily go through it and understand. But I am not from computer science. I'm not from engineering, so it's very hard for me to decipher things. So I'll use examples instead. See, suppose you have 4 rows of data. Okay. So the first product that you pick in is named alpha. The second product that you pick in each of those cases is beta. And the third product that you pick in is sometimes epsilon, sometimes theta. So what can you infer from this? So alpha is the primary item that I'm picking up each and every time. Like shoes. I'm going to buy shoes from Woodland only. Nothing else do I want from Woodland. One fine morning, I go to Woodland, pick up a pair of shoes, and suddenly I think, should I buy a pair of socks? So from the next day onwards, I keep on buying socks with shoes. That is the beta. Socks is the beta. Suddenly, I feel that I should buy shoelaces, or suppose, say, something which enhances the shine of a shoe. That is the cream that we use instead of a polish. So it may happen that sometimes I buy shoelaces, sometimes I buy the polish, the cream, whatever. So the primary item is alpha, that is the shoe, the pair of shoes. The secondary item is the beta, that is the socks. And the tertiary item is sometimes the shoelaces, sometimes the shoe polish. Okay. So as we can see, 100% of the times I am going for alpha and beta together. 50% of the times I am going for alpha, beta, and epsilon. And again, 50% of the times I have alpha, beta, and theta. So this is a kind of pattern that is present in the support. This is already present in the data. Okay, this caters to the support. Whereas it may happen that many retailers will not have such inherent evident patterns in the data. This is a very tailor-made data set. Okay, this is not a real life data set. Whereas a real life data set will be having too much anomalies over there, too much non-matching things. We need to mine those data sets and need to find out which is the simple equation that we are getting. This is a simple equation. We need to find those simple equations from the real life data, and that is the whole task of an analyst over here. So coming to a more complex example, look at this particular data set. Okay, this data set, item sets. Okay, so what we have is like The first person who has bought products 1, 2, 3, and 4. The second person has bought 1, 2, and 4. Third person 1 and 2. And likewise, there are total 1, 2, 3, 4, 5, 6, 7. 7 persons who have purchased, and we have recorded their transactions. So accordingly, we have people who have bought all 4. Some have bought 1, 2, and 4. Some have bought 2 and 4. So what we'll try to do is we'll try to find the individual occurrence of each of those items in this transaction data set. So as we see, product 1 has occurred 3 times. There is in the first row, the second row, and the third row. Nowhere else is product 1 found. Next comes product 2. Well, it is almost present in all rows except the second last one. That is, it has a support of 6. Did you get me? Any confusion? People online, any confusion? So I'm proceeding. So what happens is, like, we just break down the entire transactional data set and try to find the frequency or the support. Frequency is a raw term for support over here. So 1 has support of 3, 2 has support of 6, 3 has support of 4, and 4 has support of 5. Now our task as an analyst will be involving a subjective call, like which threshold value of support do we consider for analysis. Suppose my manager comes up to me and tells me find out all those products which have a minimum support of 3, that is at least present 3 times in this raw data set. So 1, 2, 3, 4, all are present 3 or more times, right? So I'll be selecting all those items 1, 2, 3, and 4 because all of them are frequent, at least occurring 3 or more times in this raw data set. So this particular data set gives me an idea that each item individually is frequent. That is, people will be going to buy 1 or 2 or 3 or 4 at least to the level of frequency that I need, that is 3. But the calculations are not that easy. I mean, whoever goes to a shop is there is very little probability of that person going for a single product. It may happen that that person buys 2 or 3 products at the same time. In that case, whenever we combine products, the calculations get complex, and we will try to address that calculation at this algorithm. So earlier what we did was like we addressed the singleton sets, that is 1, 2, 3, 4, and so on. Now what about the pairs? Let's see. Out of the original data set, if we go pairing products like 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, likewise, what happens is, like, the first item in the raw data set, see 1, 2, it's present over there. The second item also has 1, 2. The third item has 1, 2. But the rest of the rows in the original raw data set doesn't have the product 1 and 2 together. So definitely those particular line items or rows do not have support for 1 and 2 together. There is 1 and 2 occurring simultaneously is supported by the first 3 rows only. So it has a support of 3. 1 and 3 together, it has a support of 1 only. See the first row. Nowhere else you can find 1 and 3 together. Now 1 and 4 similarly is present in 2 rows. There is the first row and the second row. Nowhere else you can find 1 and 4 together. 2 and 3 has support of 3. There is first row, fourth row, and fifth row. 2 and 3. Likewise the other combinations that I have made. Now remember what I did was, like, I sought a threshold value of support to be 3. At least 3 or more should be the minimum support value, right? So what has happened, we see 1 and 3 and 2 and 4, 1 and 4, they do not support our threshold value. They have a frequency of support less than 3. So we cannot build rules based on the combination of 1, 3 or 1, 4. So whenever a basket that I have already selected has the product 1 and product 4 together, we cannot go on to expand that particular rule. We cannot predict on the basis of the rule. 1, 2, it's okay. 2, 3, okay, 2, 4, okay, 3, 4, okay, but 1 and 3, 1 and 4, then and there stop that particular rule. Okay, there's no point in trying to predict because it does not match our criteria of minimum support, right? So this was done with the pairs. What we can do is we can extend this, okay, to triplets, quadruplets, and so on. Like suppose we have 1000 unique products. Suppose we can make a combination of 1000 products and try to predict which will be the 1001st product, or we can make a combination of 999 products and try to predict which will be the 1000 product. Likewise, so in those cases, those are extreme rules which are not viable in practice. Okay, we do not go for such a rule which has, I mean, 10 or 20 products on the left hand side and one product on the right hand side. Those are not viable rules. We might have 5 products on the left hand side and 2 or 1 product on the right hand side. That might happen. That is viable. But 10 products or more than 10 products on the left hand side is not, worth spending money on. Okay, that rule will be very weak actually. There's a point that is already, I mean, observable. No point in trying to predict that particular rule. So you can continue with the triplets and quadruplets, and I need to mind one thing, that is 1,3, as I have mentioned, cannot be expanded further. So if you include any other item into that set and try to expand into triplet, quadruplet, that will not work, because 1,3 as a basic, as a unit itself is failing. So there's no point in associating any other item into that basket. There's no point. There will be no rule against that. Any questions online? So I'm moving on to the next slide. So what will happen is, like, we have a data set. Okay, so this data set will be having, which will be covering in R, will be having 2 columns. One will be the invoice number, the bill number, cash memo number to be specific. The item will be the item code. A single cash memo might have multiple item numbers, like we usually have, but not the other way around. So we'll be trying to build 2 different types of rules. One has high confidence but low support, and the other one has low confidence but high support. Okay, the second one, that is low confidence, high support, is very rare. I mean, it's nearly an unachievable task to obtain, whereas the first one, the first set of rules, will be practicable. Okay, and for that we'll be using the Apriori algorithm. So what is Apriori? I mean, anyone from statistics or having any idea what is Apriori or prior probability? Anyone online? Any concepts about, any idea about prior probability or a priori? So let me explain what is a prior probability for the time being. So like we have done P A given B, probability of A given B. So what is the formula for that? Probability of A given the information, exactly, conditional probabilities related to conditional probability. Probability of the occurrence of the event A given that the event B has already occurred. When you are given the information that B has already occurred, what is the probability of occurrence of B? So that is a conditional probability from Bayes theorem. So what happens is, like, if we try to find out the probability of A given B, we have to do a probability A intersection B by probability B. That is the usual rule. So what is probability B over there? It is the prior probability. Okay, that is the a priori. That is, in Latin we call it a priori. It is also called prior probability. So a priori algorithm is somewhat based on that prior probability of Bayesian concepts. So we'll look into it. We'll try to figure out what amount of information can we mine from this data set given some of the items have already occurred in the market basket? That is the whole idea of a priori, applying a priori in market basket. Given the information that I have bought 6 products, the probability of purchasing the 7th product, what is the probability? That is the question, given the prior probability of the 6 products that I have already bought. Okay. So I'll be moving into the R code. So should we have a break for 5 minutes or should we go into the R code? Sure, we're moving into the R code thing. Guys, before we move on to the ultimate coding stuff, any questions? Yeah, sure. Okay. So what is your name? So Sandeep here has a question that what will be our task as analysts? I will disagree with you from at one particular point that we are not supposed to run the algorithm. Running the algorithm is different from developing the algorithm. Developers will develop the algorithm that is already developed. We have to run the algorithm actually. We have to understand how to apply this algorithm and what parameters to change. That is kind of an art, not a science. So there's no rocket science, no rocket logic by which we can tune the parameters and set the algorithm as per the need of the problem. We have to understand by reading the problem. Say suppose I have a data set from a small retailer. In that case, what can be the threshold value of confidence? What can be the threshold value of support? That is not written over there. Any kind of statistical table is not present for that. So sorry, you have to run those algorithms time and again, and you have to understand what is the optimal value for those parameters. So the algorithm code is always present everywhere. Okay, you need to just first, for the sake of running it, copy it down, check the parameters, input the data set, and do some iterations. First you do a model. If it is not suited your purpose, it is not suitable, go for a second model. Likewise, go do some iterations and fix on a set of 2-3 models which you can recommend to the client. That this is the ultimate rule that I, as an analyst from my experience, recommend to the client, and you can implement this on your e-commerce platform. That is the ultimate target. Definitely. Exactly. Exactly. That algorithm, the steps, the structures is already built. I didn't build the algorithm. It was already built by some researcher about in 1997. If you read the original theoretical paper, the PhD paper, it is an age-old paper. Okay, so there they have mentioned, but it was later developed into R by 2002 or 2003. So they have already built it. We need to apply it just by understanding the business needs. Yeah, sure. Okay. Sure. Can I have a marker, Pratik, if possible? Okay, so Excel. Shoptoshi, do the sellers take help of the analysts to set the rules? Yeah, kind of. They, if they do not have that in-house capability of setting the rules, they go for outsourcing of these algorithms and to get a decision on the based of that. So does that answer your question, Shaptarshi? Sure. So let me try it on doing so. So I'm just explaining the concept of lift over here and the Lorentz curve because some of us have doubts regarding this. So suppose I take a axis like this. Okay, this is the y, this is the x. Okay, so if this is sorry, so if this is the 45-degree line, suppose, okay, suppose this is a 45-degree line, which means lift equals to 1 in our case. That is, the confidence or the support on the of the products on the left hand side is exactly equal to the support of the products on the right hand side. That is, this particular zone has the same amount of information as this particular zone. Nothing much, nothing more, nothing less. So a lift greater than 1 will be giving you, just a second, a, uh, a kind of curve like this, okay, which is deviating from the original 45-degree line. There's a deviation. Whereas lift less than 1, which is a very rare case. I mean, people do not even present those cases because those are useless. Might have a lift like this, which is less than. Okay. So this is negative, right? And this is positive. So lift in positive, there is greater than 1. Greater than 1, there is positive lift. Over here positive means greater than 1, okay, not 0, not in terms of 0. If it is greater than 1, that means we have a positive feedback. There is a positive rule that we have built, and if we have lift less than 1, we have a negative rule. So this is the 45-degree line, which means it is indifferent. We cannot judge anything, we cannot predict anything. But if it is on the upper corner, on the upper zone, to the left hand side of the line, that means we have a certain amount of confidence with which we can predict. That's the entire. So this curve in economics, this curve, this red one, is called the Lorentz curve or the lift curve, by which our model lifts the tendency of people buying the similar types of products or the pattern. Okay. So I'll be going for the algorithm in R. Let's see. Yes, Shovik, if it's intermingled with the 45-degree line, that means it's close to 1. Okay, it's close to 1. In that case, there is no use in, there's a point in using that particular rule. I mean, you cannot decipher what is the effect. Is it positive or negative? You cannot decipher. Like if we have like an F statistic of an overall model of regression less than 0.05, that means the model as a whole is significant. Whereas if it is greater than 0.05, much greater, it means that it is not useful. Whereas if it is equal to 0.05, we cannot make a call that easily. Yeah, sure.
Number of iteration in the Apriori algorithm. What it actually signify the support increment of the support.
Just a second. So the number of iterations that we need to make to come up with a satisfactory rule. It means that it necessarily signifies that if we set the confidence of the support to a higher level, we need to reiterate and find a better model. Every time we go for a mediocre model, we need to reiterate on that model and go for a better. Okay, until and unless we are satisfied as an analyst or someone who is going to prescribe that model to the client. That is the thing. I mean, whenever you go for in a linear regression model, we sometimes do iterations of the same model just by, I mean, eliminating some of the variables, incorporating some different variable, trying to take a logarithmic transformation. We do because we want to iterate the model and get the best out of those things that we're doing. I think we need to get started, right? It's not installed. Yeah, yeah, sure. That's there. I'm changing the pane structure, okay, because it's comfortable. I can move to the bottom actually. It's fine. Yeah. Oh, thanks. Apply. So let's start. So whatever you'll see in the upper portion, I mean the towards the beginning of this R markdown is something which I have already explained in the slides. So I'll just move in into the original application. Okay. So by the way, how many of you online or offline have used R markdown apart from the usual R script? Anyone? So okay, so Shovik, you will find that it is a very interesting platform to run R codes, which is a kind of enhancing feature of R Studio. It is not applicable in R GUI. You cannot use R Markdown in the normal R. You have to have R Studio installed. Okay, so what happens is like you can use it in the form of a book, a notepad or a book to write codes, to explain those codes, the working of those codes to anyone. So it is kind of interactive and a rather documented format. Okay, our code script is something which is very raw, which people who themselves understand and do not need to explain it to others use. Where R Markdown is best suited, or R Bookdown, there's another format for explaining people or to take sessions like this. So what I'll do is I'll try to change the path. Just a minute. So let's start. Okay. So you will be receiving this R Markdown code script, and you'll be finding this entire data set that I'll be using in this link. Just press shift and click on this link to, or you can copy this link. It's a Google Drive link, and okay, go there and download the data set. So let's start. So first we'll start with setting the path as usual. So anyone acquainted with R over here in online and in offline? Fine. I'll be making it at parallel for both the groups. So what happens is like set WD means the working directory setting. Definitely you have to set the working path for any kind of application, any software that you use. You have to change the working directory from the default mode to the one that you want to use, where your data is actually stored. Okay. So do not go for the coding thing, the coding jargons. Just look into the output that will come up. So what I'm doing is I'm reading. Okay, I'm reading the data set into the R environment. And by the way, the data set is Apriori transactions reduced. It's in a CSV form. Okay, so I'll show you what is the data set actually like. So this is a simple data set. Okay, so can you see the rows? So this is the invoice number, the number of the cash memo, and this is the item. Okay, you might find that invoices are repeating. Why? Because every invoice has a unique number, right? So I have just got this data in a raw format. What happens is like these two are same invoices, these three rather are the same invoice, and they contain these three products, these three items. So if I merge this into one single cell, that would be representing one particular product. So instead of that, I have kept it in a distinct format, in a different format. But we'll be trying to transform this particular format into a format which is suitable for R to handle the data. Okay, we're looking into it. So we have like 40236, that is like 40,236 rows. Okay, it's a pretty vast data set for customers, but not that vast to go for higher degree of support. Okay, so we'll be reading it just a second. Let's start. So what happens is like we have by df is the name of the data set where I am storing this CSV file. Okay, so let's see, once I have read this data set into R, we have to see what is the structure. I mean the structure that we had seen in the Excel, does it match with the structure in R? Let's see. So for that we have structure, str structure. So if you look at the left hand panel, the right hand panel is somewhat clumsy. I don't know why. I think there's this version of R is somewhat backdated maybe. So if I look at the structure on the left hand panel, see, it's showing a data frame. Okay, the entire data set is a data frame. So what is a data frame? It's usual like a data set with structured elements, like we have columns, we have rows. Okay, so data frame is the class or the type of the data set, and we have two columns like invoice and item. Those represented by dollars are the column names. Okay, so invoice, this column is the item number, and is the invoice number, and item is the product number. Okay, so we have factors. Factor means categorical variables. What we call in statistics is categorical, like high, low, medium. It is categorical, it is not numeric. This data unfortunately have been converted to factors. We need to rectify this first, otherwise the data won't operate properly. It might be some problem of the data present over there. Why is it like this? I mean, oh, okay. Is it okay now?
Yeah.
So can I turn around and just run it? So now the first thing that we need to do is like sort the data set as per the invoice number. So let's sort it. So what happens is, like, if we see what happened over there is like the invoice numbers were sorted. See, 110002 followed by 110003 and so on. So we took out the first 6 rows of the sorted data set and tried to show what is present. This is like visualizing what is present in the data set before going for the actual algorithm or the operations. So we, in the left hand column, we have invoice. Yes, Pritha, I'll address this question. Why do we need to convert the product number into factors? So product number is like the items, and their numbers are in alphanumeric form, 340-7800. This is the usual type maintained by Walmart, as far as I remember, or it may be some other retailer. It depends upon the retailer. So 340-7800 means 340 is the stack number, the shelf number, and 7800 probably maybe the actual item number. That is, we have selected the 7800 numbered item from the 340th stack. So overall the item is coded as 340-7800. That is the item number or the product number. So this is in alphanumeric form. It is not a pure number. So we need to convert it or keep it in character or factor, whatever. Whereas the invoice is in a pure numeric form. Okay. Since it is a pure numeric form, we can convert it into number without any hassles or any hesitation. Yeah, item is already in a factor format, but invoice is not. So we are not going to change item. We are going to change the invoice format, as correctly spotted by you. Sure. So we saw what the head was like. Yeah, this was the head. Let's see the tail. That means the last 6 rows. The last 6 rows are kind of similar, 400 or 4000, 40,059, 40,060 likewise, and the items are similar. Okay, like the pattern is similar. Let's see. So as Pritha mentioned, why do we need to convert? The invoice number is purely numeric. There is 1 2 3 4 like roll numbers that we have without any characters. Some people have roll numbers like C1000, C1001. Some have roll numbers like 1000, 1001, 1002. So since over here it is in the format of a pure number, we can convert it into numeric. So see, we just over here we converted the invoice column into a numeric invoice column, which was not present over there. Earlier it was. Yeah, we are converting the original factor variable to a numeric one. So that's why the class of invoice is numeric is showing over here. So just like the previous case, if you look at this, see, sorry. Exactly, the invoice number has to be unique. Actually, it has to be unique. See, the invoice has been converted to num, that is numeric. Okay, earlier it was like factor. So if I go for the earlier one, it was factor. This was the earlier data set df, and df sorted is the latest one that I am using. So invoice earlier was factor, now it is numeric. It will be easy for me to handle such data since it is converted to numeric. Let's now we have sorted by the invoice number, but we haven't sorted by the item number, right? The product number, the product ID. One particular cash memo might have several items, but for our analysis we need to sort by those product numbers as well. So let's sort it by the numbers. So class of item remains factor. I haven't changed it. Now let's see the actual structure. Yes, Troikot, we can do that into two separate columns, but what will happen if we segregate into two separate columns and name one as the shelf number and the other one as a product number? What will happen? We cannot incorporate three variables for determining these rules. Okay, for a priori specific, we have to have one transaction variable and the transaction ID variable, and the other has to be the product ID variable. So if we segregate it, there might be some loss of information into the algorithm. Okay, because the shelf number will be redundant over there. It might be, I'm not saying it will be, it might be. So earlier what was happening was like, this was invoice, okay, and correspondingly we had the items. Let's view it in table format. Let's view it. So see, this was invoice 1, invoice 2 likewise, okay, item number likewise. 5 had a reputation, 2 had many reputations, okay, so the invoice 2 had number of items over there, multiple items. Likewise 10 had multiple items. Okay, so what we'll do is we'll try to concatenate things. If 10 has this item as well as this item, we'll try to put this item with a comma beside this one. This will enable us to understand what are the products that is present or that are present in a single transaction, in a single cache memo. This is reshaping the data. Like we have a flat file with different items for different invoices. We try to accumulate all those items belonging to the same invoice and present one row for each invoice. Like I'll take an example. Ivy Kolkata. Okay, the number of students or participants in Ivy Kolkata online, and the number of students present or participating in Ivy Kolkata offline. So we have one column like Ivy Kolkata, next online, next we have 50 students. Again, we have Ivy Kolkata offline, 150 students, suppose. So the previous arrangement was like Ivy Kolkata online, student 1, Ivy Kolkata online, student 2, Ivy Kolkata online, student 3, likewise. Now what we'll be doing, we'll be trying to have one single row, Ivy Kolkata online, student 1 to student 50. Next will be Ivy Kolkata offline, student 1 to student 150. This will be the format that will be preferred for further algorithm, further practice of this algorithm. Let's see. So for this, we have a function from the plier package. You will be learning while doing our classes over here. That is ddply. So I'm not going into the details of the package. What it does is it takes up one row at a time. If it matches with the invoice, it just takes a transpose of that and adjoins it with the originally present data set. So we'll see what happens. So this package is not installed. Do we have a net access over here? Can we install this package? I think there's a problem with this. This package is not being installed. File. So can we download it from the zip file? So what? Sometimes whenever we get stuck, what we do is like we go to the site of CRAN. We go to the packages and search for plier. This is just a second. This is the one that I'm looking for. Okay. Yeah, we can also search for it in RStudio, definitely. So I'll be downloading this zip file. So it's downloaded. Okay, so we'll be trying to locate this folder. So what we do is we go for installing the package from a local repository. Where's the download? This is the one, the package that I've downloaded. So I'm installing this. So it is installed. Okay. So I'll be calling this package. Okay. So RCPP. There are a lot of packages missing, I think. RCPP. Hold on. This time it's loaded. Yeah, fine. So we call the package plier and try to reshape the data. Okay. So what happens is like we have reshaped the data. I'll explain what is the structure, what is the difference in the structure. If we look at the structure, we'll see earlier there were repetitions of several invoices, right? Suppose 110003 had multiple repetitions because there were a number of products. I'll just show it once again. So like 2 had number of products, multiple products over there. So what we expect over here, see, there are 3 products corresponding to this invoice. Over here that we have done, this 3402090 will be put over here with a comma, and 400-1390 will also be put over here with a comma. So let's see what happens. Yeah, TF2. Yeah. So we want to see what is the latest shape of this one, right? See, earlier corresponding to 110698, there were at least 3. There could be more because the first 6 rows had 3 items corresponding to it. But whenever we go for this transactional data transformation, we find corresponding to this particular invoice, we have a lot of products. Okay, like starting from here till here, there were a lot of products. You can't even count the number of products. So what has happened? It has changed from a longitudinal data set to a flat file. The structure of the data was one below the other. Now it's one beside the other. Similar rows, one beside the other. So this is not very important, but still I just try to show it. Let's see. So again, we convert the sorted data set. Sorry, just a second. Yeah. In every invoice, we have lots of products. Exactly. In every invoice, we have lots of products. So not lots, but multiple products. So we try to concatenate one product beside the other and place them in a similar format so that it is useful for our analysis.
So when you sorted the data, how is
Yeah.
sorted?
It's sorted according to the transaction ID or the item, cash memo number.
Means that invoice number.
Invoice number, exactly.
So in the previous data for invoice number 98, whatever written over there, there is 3 products.
Yeah.
And
Actually, in the first 6 rows, there were 3 products. It may happen that in the later rows, there were many products. No, it wasn't sorted. I'll be showing you. This is not sorted. Okay. You were talking about this, right? This is not sorted. The sorted one is this one. Okay. And over here, the invoice numbers have changed from 1, 2, 3, 4, like. Okay. So we do not know actually which one is 2. Which one corresponds to 2? I mean, 2 in sorted corresponds to 110698 is not sure. We are not sure about that. Okay, we have to look into it to understand. Okay, so what we do is we make use of a different data set. Is just a second. This one. See over here the same thing. I mean, if you look at the DF thing and the DF item list, you will find that 110. I mean, the first 6 rows shows some different. Invoice IDs because they have been sorted accordingly, like 110021100003 likewise. But if you look at the second one, 11003, you have multiple items corresponding to that, right? Like starting from here till end. So sorted was making the item column and invoice column numeric. For that reason, we didn't directly make use of that. We just change the shape of the data set and then we'll be making use of that so that it is useful for further analysis. Like just reducing the number of rows, nothing else. So we will be removing the invoice column so that we can make use of the item column, because the invoice column will not be required at this moment. Okay, so we'll just make invoice column as null. We'll just input null into the invoice column. So the invoice column has vanished, only the item column remains over here. So what we'll do, we'll rename this particular data set, which is v1 as the variables, into item list so that we can make use of this data set. Okay, so the same data set which was v1 has been renamed to item list, and we will be using this particular information. So for analysis, for the sake of analysis, we take an output of this CSV file, that into a CSV file, so that we can view what is the ultimate structure. Let's see what is the ultimate structure. So this is the CSV file generated. Okay, the name was df item list, was the name of the CSV data set. We created a CSV file by the name of item list.csv. Let's see what is the structure. See, can you guys see it online? Yeah. So this is the item list. Invoice 1 had one item, invoice 2 had multiple items, and Excel has carefully separated them into different cells. Okay, like 5 has 2 items, 6 has multiple items, 9 and 10 has a number of items associated with it. Okay, see, over here you will find many other invoices with a lot of items over there. Our task, our challenge will be to find out, given this amount of items in the left hand side basket, what will be the next item in the right hand side basket. This will be the challenge actually. So if I look at the R code, I'm just closing this. So I will make use of the library A rules, which is related to Apriori algorithm. Okay, let's see. We have to download the package again. So we install the package. Let's see. Yeah. I'm just so yeah, this is loading. Yeah, this is loaded. Fine. So we'll be making use of the CSV file that we have saved. We have loaded it. We are loading it into R in the form of a dataset named transaction TXN. Okay. So let's see how it behaves in R. See the structure. The structure is just like what we wanted. The transaction ID is 1, and the item list corresponding to the transaction ID are this. Transaction ID is 2, and the corresponding item list is this. Okay. Likewise. So a same transaction or same cash memo, they have multiple items. So this will be useful for us to interpret in R. So we are just changing the nature of the dataset. The character is being changed. Now, this is the ultimate thing. We are trying to form a rule by which we will find a pattern in the customer preference or the customer purchasing preference. Notice over here we have a support of 0.0001. What we have done, we have intentionally kept the support a little low, while the confidence is on the higher side, 80% confidence. The support is like 0.001, that is like a 0.1% confidence. Okay, and the second thing is, second rule that we are mining is high on support, a little high on support, there is 1% support, and a little low on confidence, that is 25% confidence. We will try to build these two rules and try to find which one is better and which one generates more productivity or more profit. Let's see. So if I look at the output of this, we see that the absolute minimum support count is 10. That is, out of 1000 rows, if I find at least 10 rows supporting this particular pattern, we will consider as a frequent algorithm or a frequent rule. Okay, so this particular, the first algorithm that I built, the first rule that I built has at least 10 rows in the data set which supports that particular pattern. So these are the confidences 80% as I've mentioned. These are the parameters that they have specified automatically. Okay, this is the by default parameters. So we'll look at the entire structure. Let's see, just a second. Yeah, I think I have run this one, right? Yeah, this one has been run. So similarly, I run the second rule. We need to see what is the summary of each of these rules. So looking at the descriptive statistics of first rule, see, the support for this rule is minimum of 0.001 as we have mentioned as a threshold. The maximum is 0.004, which is the maximum that I can get from the first rule. Whereas the confidence minimum is 80%, the maximum is 100%. Okay, so as an analyst, what we need to make is a choice. The choice is, do we need to focus on this confidence? There is a high confidence 80 to 100, or we need to focus on the support, which is like 10 out of 1000 to 42 out of 1000, which is the logic, which is the preferred parameter. That is the question actually. Again, we have a lift of 43.72, which is less than 100%, and a lift of maximum of 640. That is like 6.4 times 640%. Okay, which is greater than 1 definitely. So likewise, we'll be trying to compare between the two rules that we have built. So look at the second rule and its summary. So the second rule has a support which is constant, see 0.122, 0.0122. That is like support is at least 1%. Okay, 1 out of 100. And but the confidence is 64 to 67. The confidence doesn't vary much. It is maximum of 67% and the lowest is 64%. Whereas the support is much higher than the previous one. Now, as an analyst, as he was asking the question, what do we need to do? These are already built. We need to choose or make a comparison between the two algorithms that we have done. Okay. So this was the first algorithm and this was the second algorithm. Remember, the first algorithm had a support which was very low, 1 out of 1000. This has a support of 10 out of 1000. The earlier one had a confidence of 80 to 100. Over here, the confidence is 64 to 67. So if my manager or the client tells me, go for support and do not look for confidence, I should definitely go for this second algorithm. If my manager tells me, you do not have to maximize the support because that is a too high a task. You need to maximize the confidence. Definitely I'll go for the first one. That is the, subjective call that an analyst makes. Otherwise, a machine cannot do it. It depends upon the business, the type of business that I'm handling. So the rest of the things that are covered over here are like converting the entire data set into presentable format. I'll show the entire output. Just a second. Yeah, over here. So I'm converting it. See, this is the ultimate result of first rule mining algorithm that we have built. That is a product like 300 to 3512, that is the name of the product, implies the second one. This one implies the presence of this one with the support of 1 out of 1000. Similarly, this one implies the presence of this one with a support of 1 out of 1000. However, let's look at the lower ones. Okay, this is the topmost ones, the ones present on the first 6 rows. Let's look at the ones at the lower end. See, These are the weaker rules. Okay, that is a combination of this many items, suppose say 10-20 items, goes on to fix that one item will be present. So these are weaker rules. Only when we get 20 items for sure in the basket, then only we can say that one more item is going to be included. Like if Sunil has gone on to buy 20 different items, then my algorithm is telling me the 21st item will be something else. This is a very weak rule actually. While the first one, Sunil just bought one pair of shoes and the algorithm is telling me he's going to buy one pair of socks. That is a strong algorithm. Okay, so we'll be looking for the algorithms present on the topmost side, these algorithms, and not these algorithms. So just a comparison. This last step is the comparison between the two algorithms. Okay, see which one is more effective. It might be the question, which algorithm is most effective, the one with a higher lift, just a second. The one with a higher confidence and low support, or a low confidence high support, which one will be effective over here in this case? Well, let's see what happens. So if we look at this one, so number of rules, okay, present in the first algorithm is like 37,190. So we have 37,190 options or rules from which we can select. However, if you look at the second rule, sorry, just a second, I think I haven't run it. Yeah. 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 So what was happening was like, there were 37,190 rules that we could predict, combinations that we could predict. However, for the second rule, we have only two algorithms or two rules that we could predict. That means the second rule, which was high on support but low on confidence, was inferior to the first rule, which was high on confidence but low on support. So it depends from the retailer. If we have someone like Amazon or Walmart, we may have a higher number in the second rule, which was high on support and low on confidence. So as an analyst, what is in it for us? We have to select which algorithm is good. That's the ultimate thing for which we get paid off. Okay, if we find that the first one is giving multiple rules from which we can select, then we are going to prescribe the first algorithm to the client. And if we find that the second algorithm, that is the one with higher support and lower confidence, is giving greater number of rules, then we have to prescribe the second algorithm to the client. That is the ultimate target for us, the analysts, nothing else. So this algorithm is already built. We need to just prescribe the client that this is the algorithm that you need to implement in your business, and accordingly you will get this combinations. Like left hand side has 5 products, and immediately you get a 6th product in the right hand side. This is the ultimate target. So if anyone wants the output of this, to see the output, I'll share the output in an Excel file. You just compare the output of the two algorithms and you'll find the difference. Okay, any questions, anyone? Regarding the output, I had to cover this one very fast, I understand, but once you go hands-on into it, you'll understand what is the difference between the two algorithms. Any questions? Any questions online? Sure, I think we are good to make a move. What about the value of items? The amount, the price. So actually the price or the item value, whatever you're talking about, the currency or the amount is not relevant over here, because sometimes it happens that we buy a very high-end product, like something which is in thousands, along with we buy something which is in hundreds. It might happen. Like shoes from Woodland costs about 7,000, 8,000 sometimes, and socks from the same shop might cost about 500, 800, whatever. So something is in thousand, something is in hundred. We cannot compare the amount. Okay, so the item value or the price is not relevant over here. Just we need to just focus on the customer's tendency or the pattern of the customer to associate things. That's it. I mean, we cannot associate milk with shoes. Nobody in general goes for buying milk and shoes together. If that is the case, that is an outlier, definitely.
Maybe
Yeah.
deciding the price for bundling of items.
Yeah, exactly. That is a separate algorithm.
Retailer, I would try to say that which item is purchased with which one. Maybe as a
Yeah.
market, I can price the items and accordingly looking for the support of which item supports which one.
So that comes under pricing analytics, which is also used over here. So pricing scheduler, I'll get back to you, Shoptoshi, just a moment. So pricing scheduling or pricing modeling is little different from market basket modeling. Okay, pricing modeling means what should be the price of a particular product based on its demand and supply and past data. That is what we try to predict as a pricing analyst. But it has something, as you are mentioning, it has something to do with the customer's pattern of purchase. Definitely it has, but in that case we do not have only two columns like the transaction and the cash flow. We do not have only two columns, we have multiple variables. Okay, so that is more of a multiple linear regression or kind of other algorithms. Not a market basket analysis. So a priori won't work over there. There will be other algorithms. So Shoptoshi, what was your question? Can the time period of a customer spends in each location be used predictor? Okay, so one thing that I didn't mention intentionally was that you can use 1 year or 1 month or 1 day or even 1 hour as the time period for which you have recorded the transactions. So it depends upon your choice. So for Amazon, they analyze it month by month or quarter by quarter. For a daily retailer, he may be looking on his daily sales. He may be focusing on his daily sales. So he'll be collecting all those invoices each day and trying to figure out what is the pattern of sales. That's it. So if you are recording transactions, you have to choose, you have to make a subjective call regarding the period of observation, maybe 1 year, 1 month, whatever. There's no specific hard and fast rule for that. How to ascertain the price range of the complementary product? It can range from 100 to 1,000. Same complementary product can be varied ranges. Yeah, so if you are looking about, I mean, fixing the price for the complementary product, sorry, could you repeat your question, Shoykot? Should I unmute?
Muted.
Uh, uh, Hello, this is
Yeah,
Shoikat.
yeah, sure.
Yeah, my question is that a person who is purchasing a laptop, let's say a person who is purchasing an Apple laptop and a person who is purchasing a Lenovo laptop. Now, both the products have a different price range. Now, person who is purchasing a Apple laptop will go for a keypad or anything that will price a higher range, in the higher range, let's say. That with the person who is purchasing a Lenovo laptop. Now, whenever
Yeah.
I'm providing a complementary product to that purchase, now should I give the same complementary products or I will give a higher range of complementary products to the Apple purchaser and a lower range to the Lenovo purchaser?
So the second thing that you mentioned,
Hello?
hello, can you hear
No,
me?
no. Yeah, I can hear you.
So the second thing that you have mentioned is right.
That's fine.
Shrikant, can you hear me?
Yeah, you can.
So the second thing that you have mentioned,
Now you can.
the second thing which you have mentioned, like people who buy Apple will be recommended. Guys, can you hear me? Okay, so somebody who's purchasing Apple, it's necessary for the algorithm to predict something of the class of Apple or recommend something which is nearby to the range of Apple products to that particular customer. If somebody is buying Apple and if my algorithm recommends something like Samsung, Samsung notebooks or smaller notebooks, then that is a bad algorithm, I must say. A person who is buying Apple of a range, say in 2 lakhs, 3 lakhs, may be recommended an Alienware from Dell or maybe some business class laptops from Lenovo. It's not about the brand, it's about the class or the performance class of that particular product. So if somebody is very much, addicted to Apple or loyal to Apple, that's a different thing. We have to, I mean, recommend things from Apple only. But if somebody is open to choose between different brands of the same class, then definitely Apple buyers will go for something like Lenovo ThinkPads at the higher end or Dell Alienwares of very high end. That's the most you can ascertain from this end. Otherwise, we have to delve deep into the data and find out what can be the possible combinations. So did that answer your question? Thanks. So guys, we are ending this session. If there is any question or you want to clear your doubts, feel free to reach to Pratik. Okay, he'll be conveying your queries to me and definitely I'll answer one by one. Okay.
Guys, we'll also upload the video of the recorded session on our YouTube channel. So if you want, you can. And the slide decks will be given in the link of the YouTube channel, youtube.com/Ivy Pro School. You'll find in the latest videos, you'll find this by day after tomorrow. Okay, and then the links would also be given to download the slide and the data sets. Thank you, Arko. Thanks for being here. And thank you, everyone, for joining in the session. I know we've taken a little more time. As you can see, this is a little comprehensive session. So maybe I know some of the people who do not have statistical background or have not done the course yet completely. So may find a few things a little more challenging than the others. But, it's a incremental learning. At least you must have understood basic application of market basket analysis, which is also an important thing to take away from this session. Alrighty, guys, thanks a lot. Thank you for joining in today's session. Bye bye.
Thank you.
Thank you, everyone. Bye bye.